Hello, a very good morning, everyone. Welcome to the day 2 of Web3 Research. For your information, dear students and participants, we will be recording this entire meeting so that we can publish this on YouTube, and also the recording will be available for participants who are not able to. So thank you everyone for joining. We have a very special guest with us today, Jelena. She has a master's degree in blockchain from the University of Barcelona, and she is a very senior full stack developer. She will be sharing her insights into the full stack development and what are the best practices in the industry and how we can excel as full stack developers. Over to you, ma'am. Thank you very much for joining us, and we look forward to your exciting session. Thank you so much.
Hello, everyone. Good morning. I'm Jelena, senior full stack developer from Macedonia. So today I'm gonna navigate you to the full stack process. What are the current frameworks, current trends, the ecosystem, and the best practices involved. Let me share my screen. Okay. So the agenda we're going to do is first to see what is a full stack development, and also what needs someone to become a full stack developer. As I said, what are the current networks, the ecosystem, the landscape, and of course, the best practices. So first we need to define what full stack development it is. The full stack development refers to the practice of working on both the front end and the back end portions of an application. And a full stack developer possesses the skills required to handle the complete development process, from designing user interfaces to managing databases and server infrastructure. There are 5 parts in a full stack development. First is the front-end development, which involves creating the visual and interactive aspects of a website or web application. The technologies usually used include HTML, CSS, and JavaScript, along with frameworks like React, Angular, Vue.js, and also it focuses on the experience, the UX, and the user interface, the UI design. Then we have the backend development, which deals with the server side of an application and involves in managing the databases, the server logic, the APIs. Technologies used include server-side languages like Node.js, Python, Ruby, Java, PHP, along with frameworks such as Express.js, Django, and Ruby on Rails. We'll see each of them later. Also ensures data processing, storage, retrieval, as well as the business logic implementation. Then we have the data management, which involves designing, maintaining, and interacting with the databases, and includes both relational databases like MySQL or PostgreSQL and NoSQL databases like MongoDB or Redis. Then we have version control, which utilize systems like Git for tracking changes in code and collaborating with other developers. And at the end, we have the DevOps and deployment, which incorporates practices to automate and streamline the development cycle, including continuous integration and continuous development like CI and CD, and uses tools like Docker for containerization and Kubernetes for orchestration. So why is full stack development important? So first, for versatility and flexibility, full stack developers can work on both client side and server side, providing a comprehensive approach to development. They can switch between different parts of a project, ensuring smooth integration and consistency. Then we have the cost efficiency. Employing full stack developers can reduce the need for hiring multiple specialized developers, leading to cost savings for the business. And they can take on multiple roles, which is particularly beneficial for startups and small businesses. Then we have improved collaboration. Full stack developers understand the entire development process, facilitating better communication and collaboration among team members, and they can bridge gaps between front-end and back-end teams, leading to more cohesive and efficient project development. Then we have faster development time. With knowledge of both front-end and back-end full-stack, developers can expedite the development process by managing and troubleshooting all aspects of the application, and they can implement end-to-end solutions more quickly, enhancing productivity. We have the enhanced problem solving. Full stack developers have a holistic understanding of the application, enabling them to diagnose and resolve issues across the entire stack. And this comprehensive knowledge helps in creating more robust and reliable applications. The future-proofing skills is the ability to work on both ends of development, which makes the full stack developers highly adaptable for new technologies and frameworks. And continuously learning and versatility are key in staying relevant in the fast-evolving tech landscape. Holistic project understanding means that full-stack developers can contribute to strategic planning and decision-making with a complete understanding of the project's technical requirements and limitations, and their broad skill set allows for better foresight in project management and execution. So full stack development is essential for creating well-rounded, efficient, and scalable applications, and it empowers developers to manage entire projects independently, promoting flexibility, cost efficiency, and fast delivery. So we mentioned frameworks. Let's see first what is a framework. A framework is pre-built structure or platform that provides a foundation for developing software applications. It includes a set of tools, libraries, and best practices that streamline the development process. Frameworks offer standardized ways to build and deploy applications, ensuring consistency, efficiency, and scalability. And in the context of web development, frameworks can be divided in three main categories. We'll see we have front-end frameworks, which focus on the client-side part of the application. Then we have backend frameworks, which focus on the server-side logic and interactions with databases. And we have full-stack frameworks, which provide a comprehensive solution covering both front-end and back-end development. So why developers use these frameworks? Frameworks are used to simplify and accelerate the development process. They provide developers with a structured way to build applications, which can significantly reduce the development time and effort. So the key reasons are three. First is standardization. The frameworks provide a standardized approach to coding, ensuring consistency across different projects and among different developers working on the same project. Abstraction. So frameworks abstract the complex processes, enabling developers to focus on application-specific logic rather than low-level details. And the reusability, components and models built using frameworks can often be reused across different parts of an application or even in different projects. The benefits of using the frameworks are increased productivity. So they can come with pre-built components and libraries that save time and effort, and developers can leverage these resources instead of building everything from scratch. These building functionalities like routing, authentication, data management streamline the development process, allowing developers to focus on core application features. Better organization. So frameworks enforce a certain structure and best practices, making code more organized and maintainable. We have clear separation of concerns. For example, MVC's architecture is in many backend frameworks and enhances code readability and maintainability. Consistent project structure helps new team members get up to speed quickly and contributes to long-term project sustainability. Then we have the community support. So popular frameworks have large active communities that contribute to their development and maintenance. We have extensive documentation, tutorials, and forums, which are available, making it easier for developers to find solutions for common problems. And also the open source nature of many frameworks means they are continuously improved and updated with the latest industry trends and, of course, security patches. Then there is the security. Frameworks often come with built-in security features and best practices, which helps the developers protect their applications against common vulnerabilities. Regular updates from the community ensure that security issues are addressed promptly. We have scalability. So frameworks are designed to handle large-scale applications and can easily be scaled to accommodate growing user bases and increase functionality. And features like modularity and component-based architecture support scalable development practices. And the last, we have the performance optimization. So frameworks include performance optimization techniques out of the box, such as efficient data binding, lazy loading, caching mechanisms. So in the context of web development, frameworks can be divided in three main categories. First is the front-end frameworks. We mentioned already this, focusing on the client-side part of the application. The example are React.js, Angular, and Vue.js. Then we have the backend frameworks, which focus on the server-side logic and interactions with the databases. Like Express or Node.js, Django, which is basically Python, and Ruby on Rails, which is using Ruby. And full stack frameworks provide a comprehensive solution covering both the front-end and the back-end development. So we have the mean or MERN stack, like MongoDB, Express, Angular, React, and Node, and Meteor.js. So we'll take a deeper look into the frameworks just to analyze them and to make them more understandable. The three main front-end frameworks are React.js, which is developed by Facebook. It was created and widely adopted in the industry and has a large community of developers. It has a component-based architecture, which means the UI is divided into reusable components, and each component manages its own state and can be composed to build complex UIs. This modularity enhances code reusability and maintainability. React deploys a virtual DOM, which is a lightweight representation of the real DOM. When the state of component changes, the virtual DOM is updated first, and React then compares the virtual DOM with the real DOM and updates only the parts that have changed. This process, known as a reconciliation, makes updates more efficient and improves performance. The second one is Vue.js. It is designed to be incrementally adaptable. So it's a progressive framework. It can be used to enhance existing projects or to build full-fledged single-page applications. Its flexibility allows developers to adopt as much or as little of the framework as needed. It has easy integration. into projects using other JavaScript libraries or frameworks, and this makes it an excellent choice for adding interactivity to existing web applications without a complete rewrite. It has reactive components, which automatically tracks the dependencies of each component and efficiently updates the DOM when the state changes. This ensures that the UI stays in sync with the application's data without requiring manual DOM manipulation. And Angular, which is developed and maintained by Google. It is a comprehensive framework that provides a complete solution for building dynamic web applications. Angular follows the Model View Controller, or MVC, architecture pattern, which is full-featured and separates the application logic, the UI, and the user input. This separation enhances the modularity and maintainability of the code. Angular includes a wide range of built-in features, such as dependency injection, routing, forms, HTTP client, and more, and making it a powerful and complete solution for building large-scale applications. And also, it has strong typing with TypeScript, which is built with, as the statically typed superset of JavaScript. TypeScript adds type safety to the code, reducing the likelihood of runtime errors and making the code easier to understand and maintain. The strong typing and modern JavaScript features provided by TypeScript improve the overall development experience. Then we have the backend networks, which we mentioned before. So there's Node.js Express.js, which is non-blocking, event-driven architecture, which makes it highly efficient for handling I/O operations. And this is particularly used for applications that require a lot of real-time interaction, such as chat applications or live streaming services. Then Express.js, which is built on top of Node.js, provides a minimal and flexible framework for building web and mobile applications, and it simplifies server creation and routing, which makes it easier to manage the complex applications. Django, which is a high-level platform framework, a web framework that encourages rapid development and clean, pragmatic design. It makes care of much of the hassle of web development, allowing developers to focus on writing their application without needing to reinvent the wheel. Django includes a wide range of built-in features such as ORM, or object relational mapping, for database interactions, and authentications, form handling, and an admin interface. It has clean and pragmatic design. So Django follows the batteries included philosophy, providing a comprehensive set of tools out of the box. Its design emphasizes reusability and don't repeat yourself or dry principles, which help maintain a clean and efficient code base. And it also enforces consistent project structure and coding style, which makes it easier to collaborate on large projects. Then we have Ruby on Rails, often referred to as Rails. It's built on the principle of convention over configuration. This means then it comes with a set of conventions for file structures, naming, and configurations, which significantly reduces the amount of decision-making and setup required from developers. Rails provides sensible defaults, allowing developers to get started quickly without extensive configuration. Rails emphasizes rapid development, enabling developers to build and deploy applications quickly, and it includes powerful tools for generating code and scaffolding, which can speed up the development process. The framework promotes best practices and design patterns such as MVC, Model View Controller, which enhances code organization and maintainability. And then we have the full stack frameworks. We have the mean stack, and you can see how it got the name is combination of MongoDB, Express.js, Angular, and Node.js. It is known for its ease of use, full stack JavaScript implementation, and efficient handling of JSON data. Then we have the MERN stack. Again, the name is from the combination of what it uses. It's similar to Mean, but instead of Angular, it uses React. So we have the MongoDB, Express.js, React, and Node.js, and it's popular for its simplicity, flexibility, and powerful features provided by React's component-based architecture. And then we have the Jamstack, which is made from JavaScript, APIs, and markup. So it emphasizes the performance, the security, and scalability by serving pre-rendered static files and relying on APIs for dynamic functionalities. So while we are here, I want to define and mention all of these parts of the frameworks, just to be clear on that. So we mentioned MongoDB, which is a NoSQL database that stores data in JSON-like documents, and it's highly scalable and flexible, and making it a popular choice for modern web applications. The Express.js we already talked about. It's a minimal, flexible Node.js web application framework that provides a robust set of features for web and mobile applications, and it simplifies the development of the server-side logic and the APIs. Angular and React both are front-end frameworks, libraries used for building dynamic user interfaces. We said Angular is developed by Google and follows the MVC architecture, while React was developed by Facebook and uses a component-based architecture. Node.js, JavaScript runtime built on Chrome's V8 JavaScript engine, and it allows developers to use JavaScript for server-side scripting and enabling full-stack JavaScript development. JavaScript, we heard it so much so far, you already know it. So it's a programming language used for building dynamic functionalities on the client side. So modern JavaScript frameworks and libraries like React, Vue, and Angular are often used in the Jamstack applications. The APIs provide a way to interact with the backend services. They can be used to fetch data, perform operations, handle user authentication, and Jamstack relies heavily on these third-party services and serverless functions for backend functionality. Markup refers to a pre-rendered static HTML content and can be generated using static site generators like Gatsby, Next.js, or Hugo. The Jamstack benefits are performance. By serving pre-rendered static files, Jamstack sites can load extremely quickly, improving user interface experience. Then we have the security. With no server to hack, and all dynamic operations handled via APIs, the attack surface is significantly reduced. Then we have the scalability. So Jamstack sites are easy to scale since they're served from a CDN, handling high traffic effortlessly. And we have the developer experience. So separating the front end from the back end simplifies development and allows for greater flexibility in choosing tools and technologies. So Then we have the ecosystem and landscape. So we should see the tooling and the DevOps. So first we have version control systems. The most known are Git, which is distribute version control system designed to handle everything from small to very large projects with speed and efficiency. And it allows multiple developers to work on the same code base simultaneously without interfering with each other changes. Then we have GitHub, which is a web-based platform that uses Git for version control, and it provides collaborative environment where developers can host, review, manage their code. Also features include pull requests, code reviews, issue tracking, and integrated CI/CD tools. Then we have GitLab, which is another web-based Git repository manager that provides source code management and continuous integration, continuous deployment, CI/CD, and project management features. And it is known for its integrated DevOps lifestyle management capabilities. The continuous integration and continuous deployment pipelines are Jenkins, which is open source automation server that enables developers to build, test, and deploy their software continuously. It supports a wide range of plugins that integrate with various development. Testing, deployment tools. So Jenkins helps in automating parts of the development process, such as building the code, running tests, deploying applications. Then we have Travis CI, which is a continuous integration service that automatically builds and tests code changes in GitHub repositories. It is known for its simplicity and ease of use, providing out-of-the-box support for many programming languages and frameworks, and it helps ensure that code changes do not break the build before merging into the main branch. Circle CI is a cloud-based CI/CD service that automates the software development process. It supports continuous integration and delivery, allowing developers to build, test, and deploy applications with greater speed and confidence. Circle CI provides customizable workflows and robust integrations with other tools and services. Then we have containerization and orchestration, which are made possible with Docker and Kubernetes. So Docker is a platform that allows developers to package applications and their dependencies into containers, which are lightweight, portable, and can run consistently across different environments. So Docker simplifies application deployment by providing isolated environments that ensure consistency and reliability. Kubernetes, often referred to as K8s, is an open source platform for automating the deployments, scaling, and managing of containerized applications. It orchestrates the containers across a cluster of machines, ensuring high availability and efficient resource utilization. Kubernetes provides advanced features such as self-healing, load balancing, and rolling updates. The ecosystem also have package managers and building tools. So NPM, which is used, or Node Package Manager, it's used for managing JavaScript packages. So it's a default package manager for Node.js, allowing developers to install, to share, and manage the JavaScript packages and dependencies. It facilitates the integration of third-party libraries and tools, making it easier to build and maintain the applications. Includes a vast registry of packages, script running capabilities, and version management, and it helps in maintaining consistent development environment by unlocking dependencies. And then we have Yarn, which is managing JavaScript packages. So it's alternative to NPM, but that was developed by Facebook to address some of the performance and security issues found in NPM. It offers faster package installation and more reliable dependency management. Yarn provides deterministic dependency resolution through a log file, which ensures that the same dependencies are installed across different environments, and it also supports offline mode, allowing package installations without an internet connection if they have been installed previously. Then we have the Webpack, which is a powerful module bundler for JavaScript applications. It takes modules with dependencies and generates static assets representing those modules. Webpack supports code splitting, allowing for lazy loading of modules to improve performance, and it also has a rich plugin system enabling various optimizations like minification, hot module replacement, tree shaking, and so on. Then we have Parcel, which is module bundler and build tool. Fast, zero configuration web application bundler designed to be easy to use with sensible defaults and minimal setup required. Parcel automatically detects and installs necessary plugins for different file types, providing out-of-the-box support for JavaScript, CSS, HTML images, and more. And it also includes features like hot module replacement and detailed error reporting. Then we have Byte, which is module bundler and development server. It's a modern build tool that leverages native ES modules and provides a fast development server. It is designed to be extremely fast and lightweight. Features are that Byte offers instant server start, lightning fast hot module replacement, and optimized build processes. It supports both JavaScript and TypeScript, and it's a framework agnostic, working seamlessly with libraries like React, Vue, Svetle, and so on. We have APIs and microservices. REST, or representational state transfer, is an architectural state for designing network applications. It relies on statelessness, client-server communication, typically using HTTP methods such as get, post, put, and delete. REST APIs expose endpoints that correspond to different resources, for example, users, orders, and so on, and use URLs to identify resources. The benefits are simplicity, so it's easy to understand and implement, scalability. The statelessness promotes the scalability, and flexibility. It can handle multiple data formats such as JSON, XML, and so on. GraphQL, it's a query language for APIs and a runtime for executing those queries by providing a complete and understandable description of the data in the API. Unlike REST, GraphQL exposes a single endpoint and allows clients to specify exactly what data they need, and they can reduce overfetching and underfetching of data. The benefits are efficiency. As we said, clients can request exactly the data they need. Flexibility. It's easier to evolve APIs without breaking changes. And performance. It reduces the number of network requests by fetching all required data in a single request. Microservices architecture involves designing an application as a collection of small, loosely coupled, independently deployable services. Each service runs in its own process and communicates with other services via lightweight mechanisms, often HTTP-based APIs. The benefits are scalability, so services can be scaled independently based on their specific requirements. This allows for more efficient use of resources and better performance management. Then we have flexibility and agility, which development teams can work on different services simultaneously, leading to faster development cycles and more flexible deployments. Services can be updated and deployed independently. And resilience. So since services are independent, a failure in one service does not necessarily affect the entire system. This isolation improves the overall fault tolerance and resilience of the application. Then we have technology diversity. So teams can choose the best technology stack for each service based on its requirements. This allows leveraging different programming languages, databases, or other technologies. We have the ease of maintenance. So smaller code bases are easier to understand, test, and maintain. This modular approach also simplifies debugging and troubleshooting. We have the continuous delivery and deployment. So microservices facilitate continuous integration and continuous deployment practices, allowing for more frequent and reliable releases. Improved resource utilization. So independent services can be deployed in containers, allowing for better resource allocation and utilization across different environments. Another very important part of the full stack development is the testing and the quality assurance. So first, let's see why testing is important. And we have three types of testing. Unit testing, which involves testing individual components or functions of an application in isolation. And the point is to validate that each unit of the software performs as expected. So it detects bugs early in the development cycle, ensures that each part of the code works correctly independently, and facilitates refactoring and code maintenance by providing a safety net. Then we have the integration testing, which focuses on verifying the interactions between different modules or services within an application. And it ensures that integrated components work together as needed. So it identifies issues in the interactions between units that might not be evident in unit tests, validates the different parts of the system work together harmoniously, and helps uncover interface mismatches and data flow problems. And then we have end-to-end testing, or E2E, which simulates real user scenarios to validate the entire application workflow from start to finish, and it tests the application in a complete environment to ensure that it behaves as expected. So it ensures that the system meets business requirements and provides a seamless user experience, validates the complete system flow, including UI, backend services, and databases, and helps catch issues that might be missed in a unit, and integration tests, such as problems with, let's say, external dependencies or some environment configurations. There are three popular testing frameworks. First is Jest, which is a JavaScript testing framework developed by Facebook, designed primarily for testing React applications. And it offers a simple setup, rich set of features like built-in test runner and assertion library, snapshot testing for UI components, support mocking, and a spine to isolate units of code, and provides detailed test coverage reports. The second one is Mocha, again, flexible JavaScript testing network, which runs on Node.js and in the browser, and it's known for its simplicity and extensibility. It supports asynchronous testing, allows for custom test reports and interfaces, can be paired with various assertion libraries like Chai for more extensive tests, and it's highly configurable with a wide range of plugins available. And we have Cypress, which is end-to-end testing framework that focuses on providing a developer-friendly experience for testing web applications. It's well known for its speed and reliability. So real-time reloads and automatic waiting, easy setup with no configuration needed for most projects, rich interactive debugging tools with detailed error messages and stack traces, supports mocking network requests and stubbing responses for controlled testing environments. Now let's see the best practices. So we have to have some standards and guides while coding, and it's important of maintaining and be consistent at those coding standards. First, because of code readability. So it will be easier to read and understand for all the team members, and this is crucial, especially for collaborative environments where multiple developers work on the same code base. And even if we are our own team or one developer, maybe we'll need to come back to a feature that we worked long time ago, so it will be easier to remember and to get back to that point and faster. Then we have maintainability. So uniform coding styles help in maintaining the code over time. It becomes easier to debug, to refactor, to extend the code when it follows a consistent format. We have reduced errors. So adhering to coding standards can prevent common coding errors and improve code quality. This leads to fewer bugs, smoother development processes. We have collaboration. So consistent code is easier for new team members to learn and contribute to. It ensures that everyone is on the same page regarding how the code should look and behave. And of course, professionalism. So following coding standards reflects professionalism and attention to detail. It demonstrates that the development team cares about the quality and consistency of their work. There are, of course, tools for this. So we have the ESLint, which is a widely used tool for identifying and fixing problems in JavaScript code. It enforces coding standards and helps maintain consistent code quality across the project. So the features are rule enforcement. So it allows developers to define the set of rules that the code must adhere to. And these rules can be customized to match specific coding standards and conventions. We have error detection. It can detect potential errors and bad practices in the code, such as undefined variables, unused variables, or syntax errors. ESLint also can automatically fix certain types of issues, such as formatting errors, making it easier to maintain the code consistently. Then we have Also, ESLint supports a wide range of plugins that can extend its functionality to cover additional languages and frameworks. The other tool is Prettier, which is opinionated code formatter that enforces consistent style by parsing code and reprinting it with its own rules. It removes all original styling and ensures that all outputted code conforms to a consistent style. Prettier formats the code automatically, ensuring that all code looks the same regardless of who wrote it. Also supports variety of languages like JavaScript, TypeScript, CSS, HTML, JSON, and more. Prettier integrates seamlessly with popular code editors like VS Code, Atom, and other tools, making it easy to incorporate the development workflow. And by enforcing a consistent code style, Prettier reduces the amount of time developers spend on code reviews related to the style and the formatting issues. And usually it's what it's used in the development process is combination of these two. And that combination enhances the code quality. So using both the ESLint and the Prettier together ensures that the code is not only well formatted, but also adheres to the defined coding standards and best practices. And they can be integrated to run together, which ESLint handling code quality and Prettier managing the code formatting. This can be achieved through configuration files and plugins that ensure that both tools work in harmony. So on top of the best practices, we should also consider the security best practices. So that is also a very important part. That's why it's divided separately, so we can stress it out enough. The importance of the securing of the applications is first for protecting the sensitive data. So we have to ensure as developers that all the personal, financial, and proprietary information is safeguarded from unauthorized access and breaches, because compromised data can lead to identity theft, financial loss, reputational damage, and so on. Then we should maintain trust. So users trust organizations to protect their data. So a security breach can erode this trust, resulting in first loss of customers, also legal consequences, even financial penalties, and so on. Compliance and regulations. So many industries are governed by strict regulations. You already know some like GDPR, HIPAA, PCI DSS, and so on. So they mandate specific security measures, and non-compliance can result in severe penalties and also legal issues. The fourth very important point is preventing financial loss. So security incidents can lead to direct financial losses due to fraud, theft, remediation costs. So there are often indirect costs such as lost business and damage to the brand's reputation. And we always have to ensure availability and reliability. So securing attacks such as DDoS or distributed denial of service can disrupt services, leading to downtime and loss of business. So securing application ensures that services remain available and reliable. There is OWASP Top 10, which is a standard awareness document for developers and web application security. And it represents a broad consensus about the most critical security risks for web applications. So first is injection. Injection occurs when untrusted data is sent to an interpreter as part of command or query, allowing the attacker to execute unintended commands or access data without proper authorization. use parameterized queries and prepare statements, and validate and sanitize all user inputs to avoid this. Then we have the broken authentication. So it involves flaws that allow attackers to compromise passwords, keys, or session tokens, or to exploit implementation flaws to assume other users' identities. What we can do, implement strong password policies and multi-factor authentication, or MFA. Also securely store session IDs and tokens and invalidate them after logout or inactivity. Third one is sensitive data exposure. So, which means inadequate protection of sensitive data such as financial, healthcare, or personal information. Again, what we can do as developers, we can use strong encryption for data and at rest and in transit, and also implement secure key management practices. The fourth one is the XXE, or XML external entities. This one, it's a vulnerability arising from processing XML input containing a reference to an external entity, potentially leading to data exposure or remote code execution. So disabling XML external entity processing and DTDs in XML parsers and using less complex data formats such as JSON when possible will help us avoid these XML external entities happening. Then we have broken access control. Laws that allow unauthorized users to access restricted data or functions. Again, what we can do, enforce least privilege access control principles and regularly review and test access controls. Then we have a security misconfiguration, which involves improper configuration of the application, the frameworks, the servers, or security settings. What is the mitigation? Implement a robust configuration management process and ensuring secure settings are the default and remove all the unnecessary features. Then we have cross-site scripting or XSS. This occurs when an application includes untrusted data in a web page without proper validation or escaping, allowing attackers to execute scripts in the user's browser. How to avoid it? To escape or encode output to prevent execution of malicious scripts, and use a content security policy to restrict script execution. Then it's number 8, which is insecure deserialization. That occurs when untrusted data is used to abuse the logic of an application, inflict denial of service attacks, or execute arbitrary code upon deserialization. How to avoid this? We should avoid using serialization of sensitive data and also to validate and sanitize all serialized data. Number 9, which is using components with vulnerabilities. So this involves using libraries, frameworks, or other software modules with known security flaws. To avoid this, we should regularly update and patch dependencies and use tools to scan for known vulnerabilities in dependencies. And the last one is the insufficient logging and monitoring. So lack of proper logging and monitoring mechanisms that can detect and respond to security breaches. So we should always implement a comprehensive logging and monitoring practices to avoid this, and also regularly review logs to identify and respond to suspicious activities. So after seeing the best practices and the security best practices, now our, let's say, development process is near the end. We tested everything. We saw the best practices, implemented everything, even security best practices to avoid issues. Now it's time to optimize. So in order our app or web product or software that we're building to be great, it needs to be optimized so it will have it will be faster, more reliable, more securable, and so on. So we can divide the optimization. We can divide the optimization performance into parts. First is the front-end performance optimization. And we have three important here. First is the lazy loading. So there is a technique that delays the loading of non-essential resources until they're needed. And this also, this is very important for images, videos, and even JavaScript modules. So it reduces the initial load time and improves page load speed. And also it decreases the bandwidth usage by loading resources only when they enter the viewport. It's very easy to use for images. We just need to use the lazy attribute in HTML or implement some intersection observer API in JavaScript. And for the JavaScript, we dynamically just import modules using import in ES6. The second one is minimizing HTTP requests. So this will make the browser significantly speed up the page load times. So we will get faster page rendering as fewer resources need to be fetched, and reduce server load and bandwidth consumption. Then we have the third one, which is using CDNs or content delivery networks. The CDNs distribute your content across multiple servers worldwide, delivering resources from the nearest server to the user, which is beneficial for faster content delivery due to reduced latency and improved reliability and availability through load balancing and redundancy. For backend performance considerations, we have two most important. The first is efficient database queries. So optimizing the database queries is crucial for reducing the response times and improving the overall performance of the application. So we will get faster data retrieval and processing and reduced server load and improved scalability. Also, caching strategies. So caching involves storing copies of data in a temporary storage location to reduce access time and server load. We benefit from it by decreasing latency and improving response times for repeated requests, and also it reduces the load on the database and server resources. Another very important segment of the full stack development process is collaboration and teamwork. And there are two parts in this. First is the documentation, which developers usually hate, but it's the most important thing to be done. And not just to have documentation, but to have good documentation. And why it's important? First, it's important because of knowledge sharing. So documentation acts as a single source of truth, providing detailed information about the project. It helps team members understand the code base, design decisions, usage instructions, ensuring everyone is on the same page. Then it's important for onboarding. So well-documented projects simplify the onboarding process for new team members, and it provides the team with the necessary context, guidelines, and references to get up to speed quickly and start contributing effectively. Then maintenance and updates. So comprehensive documentation makes it easier to maintain and to update the project. Developers can refer to the documentation to understand the existing code and make necessary changes without introducing bugs or inconsistencies. And of course, collaboration. So the documentation fosters better collaboration by clearly outlining tasks, responsibilities, and workflows, and it helps avoid misunderstanding and miscommunications, enabling smoother teamwork and problem solving. So when issues arise, documentation serves as a reference to diagnose problems and find solutions faster, and it can include troubleshooting guides, common issues, and their resolutions. So there are three types of documentation. First one is code documentation, and usually it's consistent of inline comments, doc strings, external documentation describing the code's purpose, logic, and usage. Then we have project documentations, which is usually README files, setup guides, architectural overviews that provide a high-level understanding of the project, and user documentation, which are manuals, frequently asked questions, how-to guides for end users to effectively use the application, because not everyone is on the same, has the same tech background or the same knowledge, or they are tech savvy to use our application. Also, it's very important to use agile methodologies into the project management process. So agile methodologies focus on iterative development, continuous feedback, flexibility to adapt to changing requirements. So they promote collaboration, customer feedback, small incremental releases. The benefits are improved collaboration. So agile encourages regular communication and collaboration among team members through daily stand-up, sprint planning, review meetings. Then we have flexibility. So agile allows teams to respond to changes quickly, ensuring that the project remains aligned with customer needs and market trends. And continuous improvement. So agile practices like retrospectives, help teams continuously evaluate their process and improve their workflows. So there are quite a few project management tools, especially these days. The most used are Jira, Trello, Asana, ClickUp, and so on. And they are made so the project can be managed easier by the project manager and the team leader and so on. Each developer can see their own tasks. They have similar dashboard where they can run the sprints, they can make reports, documentation, task-based approach, cards, and so on. So it will help these agile methodologies be more naturally involved into the development process. So besides what we talked about, we should take a look at the latest trend into the full stack development for 2024. So we have micro frontends. So extending the microservices concept to the frontend allows teams to develop and to test and to deploy front-end features independently, and also facilitates better scalability and more flexible deployment strategies. So before continuing this, I think we should make a small break of 10 minutes and be right back.
Announce. Thank you, ma'am, for the fantastic session. We can have a 10 minutes break, as you said now. Participants, you can ask your doubts if you have any in the Q&A section. We can take this up later. Thank you so much. Dear participants, we are actually having a short breakdown. This is the right time if you want to ask any questions. You can use the Google Meet Q&A feature where you can post your questions and we will take this up after the session is over. Thank you so much.
I'm back. Sorry, I had a sore throat, had to drink some water. So I think you took the time to see the latest trends. So some of them we already mentioned before. What is really new? It's now with this AI era that we integrate these machine learning and AI techniques, which more and more applications are integrating them, and in order to provide personalized experiences and predictive analysis and automation. Of course, we should also see the serverless architecture, so it gaining more traction with Lambda, Azure functions, Google Cloud functions. This will reduce the management overhead, and the developers can focus more on code and on the algorithms and less on the server management. We already talked about GraphQL. Also, there are web assemblies that enhance the performance by allowing code written in multiple languages. And it's useful for applications to require high performance computation directly on the browser. The component-based architecture we mentioned before, so it promotes reusability, maintainability, and easier debugging. Low-code and no-code platforms, so it increases the adoption for rapid development and prototyping, and allows also non-developers to create applications through visual interfaces, democratizing software development. And progressive web apps. So there is a combination, the best of the web and mobile apps. And these progressive web apps are becoming more capable with features and have offline support, push notifications, and access to device hardware. So how to choose the right framework? For a specific projects. First, we need to consider the project requirements. So we should assess the specific needs for our project. For instance, if I need a real-time capabilities or frameworks like Node.js might be suitable, then we should consider the team expertise. So what is the skill set of your development team? Choose a framework that aligns with their experience to reduce the learning curve and improve productivity, and so they can start working efficiently as fast or immediately. Then very important is the community and the support. So look for frameworks with strong community support or comprehensive documentation and active maintenance. So this will ensure that you have resources to turn to when facing some challenges. Performance and scalability. So we should evaluate the performance benchmarks and scalability options of the framework. For high traffic applications, we should choose frameworks known for their efficiency and scalability. Then the development speed and flexibility. So some frameworks offer rapid development capabilities, like we saw Ruby on Rails, while others provide more flexibility and control, like Django. So we should choose based on our needs for speed versus customization, because we cannot have both at max. And of course, very important are the security features. So we should consider the security features provided by the frameworks. So some frameworks come with built-in security features and follow best practices, which can be crucial for sensitive applications. Long-term viability. So we should ensure that a framework is not nearing the end of its life cycle, and we should check for regular updates and a roadmap for future improvements. And integration with other tools. So we should assess how well the framework integrates with other tools and technologies you plan to use, such as databases, CI/CD pipelines, and of course, cloud services. And the last but not least, we should mention what are the essential skills for a full stack developer. First, proficiency in front-end technologies. So HTML, CSS, and JavaScript, and also knowledge of front-end frameworks and libraries like we mentioned before, React or Angular, Vue.js, and so on. Then backend development. So understanding the server-side languages such as Node.js, Python, Ruby, Java, or PHP, and familiarity with backend frameworks like the ones we saw, Express.js, Django, Ruby on Rails, and so on. The third one is the database management, so knowledge of both relational databases like MySQL and PostgreSQL, and NoSQL databases like MongoDB, Redis, and so on. Version control systems, so proficiency in Git and platforms like GitHub or GitLab or Bitbucket for code collaboration, version control. Understanding of APIs, so ability to design, to implement, to consume RESTful APIs. Knowledge of GraphQL for more efficient data querying. DevOps and CI/CD, so familiarity with CI/CD tools, like we saw Jenkins or Travis CI or Circle CI. Understanding of containerization, like Docker, or orchestration, like Kubernetes. Security best practices, so awareness of common security vulnerabilities and how to mitigate them, like we saw the OWASP top 10 reference list. Problem solving and debugging. So as full stack developers, you should have strong analytical skills to identify and to fix issues across the stack. So proficiency in using debugging tools and techniques is a must. Also, you as a full stack developer, you need to have soft skills, which means communication skills for effective collaboration with team members and stakeholders. Time management and organizational skills so you can handle multiple tasks and deadlines. And the most important, continuous learning. So we should, as developers, we should stay updated with the latest trends and techniques and technologies in the full stack development. And we should be willing and keen to learn new technologies, languages, and tools as required. So thank you for your time and patience. And we have a couple of minutes for Q&A. I saw in the chat already someone posted a question. It says, minimize HTTP requests, deal with reducing HTTP request methods like put, patch, post, etc. Or what exactly mean? So by minimizing HTTP requests means reducing the number of times a web page has to fetch resources, especially images, videos, scripts, style sheets from the server. So this can be achieved by combining files, like using CSS sprites, and inlining small assets. But it does not typically involve reducing the use of HTTP methods like put, patch, or post, which are related to specific operations on the server. So if you minify the CSS files, and if you minify the JavaScripts that run behind, and if you, depending on the framework, if you use like Ajax framework, it will only update the changes on the UI, on the web interface for the user, and not call and not make a request to pull everything, but only the changes. So this way we will minimize the HTTP requests, which will make the load time faster, the server load less, and our app or website will be faster and working faster, which is always important, especially from user experience. And when you're developing some project, you should always think about the users. So if a user is satisfied, it will continue using your service. If you give them frequently asked questions or user manual, like user documentation, they will know properly how to use your software and not get stuck somewhere and think that your software is not good, so they will go to some other competitor which is similar. And also they will know all the features and all the options they have by using your software. So that is always important.
Thank you so much, ma'am. This was really an amazing answer. We have some more questions, ma'am. Can we have like 5 minutes for some more Q&A?
Yes.
Yes. So in the Google Meet Q&A, we have some questions. I will read some of the questions. One anonymously, someone asked how to decide which database to use in our applications when there are so many options. What are the differences between NoSQL database and a SQL-based database, and which one is preferred in the industry in general?
So, as I said, always you should think about what framework or what to choose by what is your project about, and along with the other 10 dots that we went through. But what is your project about? Is it going to be a web application or a mobile application as well, or is going to be a desktop application? So where is going to be used? What is the amount of audience it needs to, and what is the type of audience that needs to use it? And what are what is the project about? That is the point to get from what framework and what language to choose and so on. And whether you're choosing a NoSQL or SQL. So the new NoSQL, it has flexible schemas, often document key value graph, or it's column based. It's horizontally scalable. It's easily distributed across many servers. It's optimized for large scale data and high velocity ingestion. So it's ideal, for example, big data, real-time web apps, IoT applications that needs flexible schema. We said MongoDB, Cassandra, and others. So SQL is more structured schemas and relational tables. So they are not so flexible. They are vertically scalable. So adds more power to a single server. And also we have ACID compliance, which ensures reliable transactions and complex queries. And it's suitable for structured data, for complex queries, so for transactional applications. And whether to choose between NoSQL and SQL. So when you need scalability, when you need flexibility, speed for unstructured and semi-structured data, like streaming apps and so on, then we use NoSQL. But when we need data integrity, complex queries, structured data, priorities, especially in financial apps and so on, then we use the SQL. So always in everything we do, either choosing what language to choose, or what framework to choose, or what practice to choose, what ecosystem and so on, we should always start, okay, what is our project about? What is the audience is going to use? Is it going to have a live real-time updates? Are we going to use big data or a lot of data or not? Do we need flexibility and scalability, or more structured way of using it? The security is more important than the performance. We said we cannot have at max both. We have to compromise. So either we use more security and then we get less performance, or we get more performance, faster interaction, but less securities. So we always have to start with those 3 important points, and then the other 7 I mentioned before.
Yes, so that perfectly answers the question. Thank you so much, ma'am, for coming to WebSH. So we're really grateful that you covered all the major technical, all the tech stacks and the frameworks that we have. So this was really an amazing overview of all the development practices like Git and what are the techniques we should use for deployment. I hope the participants really enjoyed this session, and we will have a quiz at the end of the day. Like when all the sessions of the day are over, we will have a quiz for the participants that will include questions from this session, whatever was covered. Thank you so much, ma'am, once again. From the side of our institute, IIIT SriCity, we thank you for joining WebSH. Thank you so much, ma'am. Dear participants, our next session will start from 11:30. Thank you.
Thank you.